Gadget UK here again, back for sort of unexpected part 3 on the C16 stuff. So yeah, hopefully you saw the previous videos. If you didn't, there'll be links down below. We picked up 2 boards there from Sparks UK quite a while back. It's probably took me best part of 18 months or more to get around to looking at this. But anyway, this is the other board. We got the first board perfectly working. The state of this one is terrible. You can see it's missing so many things here. It really is. There's so many mangled things and bent things. We're lacking a port here, we're lacking the switch, we're lacking a power jack. We're probably lacking some passives and things around here. We're missing the keyboard IC there, we're missing a transistor, we're missing the heatsink, the fuse, the modulator, ferrite bead or something there, you know, an EMI thing. It's one of those little capacitors with a ferrous core in it as well. The 2 resistors we borrowed from this board that were missing on the other board. The tape port's missing, the 257s here are missing, the RAM is missing, all the main chips are missing, but we've got some TEDs. I've got a CPU replacement. We can easily replace those with 27C128 ROMs. I've got a PLA from Daniel Amantion. Got one of those spare, and other things on here I think should be relatively easy to replace. It's the ports, the main thing. The ports, the main thing. I'm not sure if I'm going to be able to source replacement ports. At the very least, we can move this port to there so that port 1 is working, and I could use it with serial maybe. So the first thing, yeah, I was thinking about, I talked about this in part 1, power switch, C64 power switch. These are normally bent over that way, yeah, the opposite way to what they are now. So I've bent the first 3 over there. We're going to need a wire for one of the connections, and the aim is to, you know, to get it to go like that. And as you can see, that's going to fit there like that. And if I bend these 2 over, they'll go through those 2 holes. It's just going to be this one here that's probably going to need a wire down to there. I'll look up these schematics to work out what these resistors are. We'll get some resistors there. I'll find something to fit there. I don't think I've got a 3-pin device, but we can just literally bridge it. It's a case of just bridging the connection across. We'll just be lacking the ground connection. I'm not sure if it's going to output video without a modulator. That could be an issue. Might have to try and source some modulator or modulator replacement or something for this. But I think this is a nice use of this, rather than just bin this. There's enough on there to mean that the work to rebuild this, it's not out of the realms of possibility. I mean, look at the LED there, look at the LED connections, they're totally bent over. I think generally though, the PCB is in good condition. That is the case, you know, there's no massive trace damage and stuff, and of course that's the way you would want to maybe scrap a board if there were too many badly damaged traces. But I think this board's alright, it's just got lots missing. So yeah, the key now is going to be trying to bend this leg here without it breaking off and get a proper spacing. Yeah, there you go. I've started to bend it like that. You can see that's not going to be far off the mark, I don't think. Let's just give that a try. There you go, it's going to be perfect. So I'll just bend that one the same, and this one's going to be a wire. And there we go, with some super bending there. It's going to fit perfectly. Yeah, I cut the little metal tabs that were sticking off here, but as I say, what I will do is, you know, get a longish, thickish piece of wire, pull it up through there, over the top, make it nice and square, and then maybe add a little bit of solder on the top there, just to support it on the top side. But that is going to do the job, isn't it? So I think at this point now, I'm going to solder the points here, trim off the bits. So we'll start on the beefy connections here. We'll do this one over this side. It needs straightening sort of this way. It's just a case of adjusting it until I get it square. You know, these are problems obviously you wouldn't have with a genuine switch. I mean, it is a genuine switch, it's just the wrong alignment, isn't it? Yeah, you can see that's going to be pretty square there, and it's nice and flat. So let's solder the other points. So let's now trim off. I can use these bits actually for those, and then it'll be the right thickness of wire. Not really wire, but you know what I mean. There's a little bit to trim off there. Right? There we go. Yeah, so you can see what I mean. It's like that. It's going to be ideal for the one that's super short. It's gone right through there, and this may, if I can just squeeze it through, I might just be able to. That might be too thick actually for that. It doesn't really need a big one there. Let's just use a resistor like that for that first one. But we will use the longer piece, this one, to join up to the one over there. Yeah. So that first one is almost through the hole here. So I'm just going to use a cheap 4K7 resistor. I'm going to stick it just a short distance in. Let's just try and gauge this about there. Bend it over. Yeah, so it's just into the hole. Solder this. Lots and lots of solder. Try and get it to follow through. Leave the resistor there for a moment. I'm just trying to fill that gap, join it from here, and then it should protrude. Yeah, it's joined up already, look. It's joined that, and I can see a little bit of it sticking out here. So I can, just trim that down on this side here, like that. That's it. So yeah, that first one is joined, which now means I can trim off this resistor here, like that. There we go. And stick this through here, like that, I think, and sort of solder it on. Yeah, that is still joined up. So yes, it's a total bodge, but you know what? As it is, it's supported. I'm just going to straighten some of these things up now, I think. It just looks like someone's not gone to it with a sledgehammer. Yeah, for the eagle-eyed, you can see, yeah, that's there, bridged almost. That was worse than that when it came to me. I did just separate that earlier on, but if we just get the fine nose pliers in there, we can just pull it, there we go, a little bit to the left, and probably crimp it a wee bit, try and straighten it. Yeah, it's a bit better. It still needs a wee bit more to that side. Yeah, that'll do, I think. I don't know how I missed this. Look how mangled that is. Let's just first of all remove that resistor away that's shorting onto one of the pins there. Let's just pull it up that way, I think. And I think we'll pull it forward because it's kind of, there we go, a bit squished over, and then carefully try and bend these. They may snap off because they are extremely bent. Yeah, that's not too bad. It's not like perfectly square. It's a lot better there. Right, the next thing I'm going to do is just get all these sockets on. So yeah, hold up to the light and just have a look through so you can see through all the holes, inspect, make sure there's no damage on both sides. And then, yeah, just have a clean up maybe with a fiberglass pen, some IPA, final inspection, get a socket on. This is where I will just use the dowel, actually. You can argue it's a little bit lazy doing this, because if you just use a little bit of braid wherever you've got perhaps a bit too much solder on the edges there, then yeah, it's perhaps better than using the dowel. But yeah, I've just got into a routine of just doing this where these buds are, were scrapped by somebody. They're not like customer repairs or not something that's in pristine condition by any stretch of the imagination, so it's nothing really lost by just doing things to speed up the process of getting this back together. There we go, socket in place. Make sure it's flat, flush and square, and then we'll just solder the remaining points. So the missing resistors, the one at the back, 3K3, which I've got here. It's one of those blue ones, but nevertheless it will do the job. So I'm just going to bend it over in much the same way the other ones are fitted, and we'll get that in. And then the one at the front is 330, so I'll just flip that over and solder that. But anyway, you can see that that's a resistor fitted. We'll do the same with the one up front, the 330. So I've unblocked any holes around here that were blocked. We do, however, have this leg here, don't we? It's actually off the RAM. This is one of the RAMs. It's come out of the chip, so that extraction was not successful. It's the chip broke when someone tried to get it off, I think. So we'll just heat that pin and just try and pull it out. Because when you heat something like that, you heat sink it when you grab it. Oh, good God. So yeah, it may. So it's such a weird angle that. Let's try and do that again. There we go. And then we'll just unblock, and then I'm going to clean up around here with some IPA, and we can get a socket on. Right, that's the RAM chip sockets on. So just the 257s and the diode. I'm going to look up the service manual for D11, no D12s or Zener. I'm still waiting for the Zeners at this point actually, although you'll have seen me fit those into the other board. I'll obviously get a fuse on, so I'll do the same thing I did before, just clean up with the fiberglass pen and the wire brush there, clean around with cotton buds to get a 1.5 amp normal blow fuse in there. And then I think we might be able to start fitting the chips, but I think before we do that, obviously, I need to heatsink this, the 7805, and just test voltages perhaps, but then we can get the chips in. D11, according to the service manual, is 1N4001. I sort of suspected that might be what it is. Yeah, the cathode is towards the top up here, so I think we'll fit this the same way they usually are, which is like anode down to the bottom with the cathode leg just bent over, like that. So yeah, we just need to just push that in there and fit that. It always surprises me, well, it never ceases to amaze me that people remove standard stuff like, you know, a 3K through resistor and a 1N4001. It's like these things are pennies. Stock them. I always stock these things. Clean up later. Right, that'll do for now, because I'm going to be cleaning around here with the toothbrush later. Let's get the fuse in. There we go. So I fitted a wee heatsink here, and put a nut on the other side as well. So yeah, being careful to make sure the legs are not short to the blooming thing and the arms. So yeah, normally it's quite a thick, beefy thing that goes in the silhouette here where this silk screen is here. So anyway, that should be alright, and it's nice and tight. It's married to the board pretty well. So I think, other than the keyboard connector, which we need later, and the tape thing, which you can do later, and the Zener diode, which you can do later, modulator, we're not sure about at this stage whether we're going to need it or not. Obviously we need the chips, but these two. So I'll just do these two, and then I'll report back. So, pinholes blocked. You can see there's some discoloration here. That's hot air. Hot air has been used to remove those by whoever worked on that previously. So we're all good to test the power. We've got the power LED ready here. None of the chips that I'm going to add are currently fitted. I haven't even checked for shorts or anything on this at this stage, but we've got the fuse there, we've got the switch there, I've got positive here. None of my DC jacks will fit that position, so I need to see if I can find anything that's suitable. Other than that, I might need to modify the PCB, drill a hole or two, just try and fit a jack there. And the ground, obviously, there. So the power supply set to 9 volts 1 amp. Let's just switch it on and off. Do you see the LED there? Switch it back on again. So I switch it off and on at this stage. So I switch it back off, and let's get ready with the probes here. And we'll just measure between ground and one of the 7.4 series. 5.69, that's a bit high on the 5 volt rail. I think that regulator might be borked, to be honest. It's like 5.69 there. So yeah, there is something interesting going on with this. Yeah, 5.68 volts. So I think it needs a new 7805. So I think the next thing we should do is get that 7805 off actually and replace that. Measuring this regular left board, we have 5 volts. I'll show you this on the meter in a sec. I'm seeing 4.92. Yeah, so I'll show you the voltage going in, just under 9 volts, and the voltage going out, 5 volts. So it is the regulator. I suspect what's happening here is something is merging with the 5 volt rail. It could be one of the other supplies that, I don't know, see the regulator's not, the Zener's not here at the moment, is it? But there's some of the supply, I think, mixing with the 5 volt. Yeah, herein lies the source of the problem. I'm glad I tried to test it this way. There's no regulator at the moment, yeah? So I was expecting the, you know, the 9 volts would come to this regulator here, which isn't there, and there'd be no 5 volts. And then maybe we'd see like a 0.6 volts or something on the 5 volt rail or something like that. That was just a theory. So it's drawing 150 milliamps, which is a bit strange right off the bat. And if I put it on the input of the volt regulator that's missing, 8.57, so it's a bit low. So we've already got a drop there. And on its output, we've got 5.88 volts, 5.9 volts almost. How have we got almost 6 volts on a 5 volt rail when there isn't even a 7805 fitted? So just looking at the schematics here, you can see the 9 volts comes in through the line filter there, through the fuser stuff, into the input pin of the 7805, and then if you follow the line up, it goes through the 20 ohm resistor and it goes to the output of where the 5 volts comes out of the regulator. So yeah, that 9 volts does get merged through the 20 ohm resistor, which is why we saw about 6 volts with no chips on the board. And it was Liv2 that pointed out that's probably just to deal with like the initial inrush and the start-up time of the 7805. Armed with that information, I fitted all the chips and cautiously retested the 5 volts, and it was okay. You can also see here the transistor of the tape port, and into the base of that transistor you can see the 6.8 volt Zener diode there, and if you follow the trace out that transistor there, it goes all the way to the motor connection on the tape port. Right, so I am going to borrow the modulator from the board we fixed in part 1. Curiosity is getting the better of me. At this particular point, part 1 hasn't been finished actually, sorry, part 2 hasn't been finished. But yeah, we can swap it back, it's not a big deal. We've got 8 solder points here, a couple of ground points here, and I think a ground point, yeah, there, and one there. We solder it actually directly onto the PCB surface there. I wondered what that blobby mess was, but that's a factory thing. So yeah, you know, there is a risk of damaging some pads and things here, but I'm just going to be as careful as I can. Right, let's try and pull that off. So, look, it's loose. It's loose on everything apart from up here, I think. Because I see all the pins here moving. I see all these anchor points moving, I think. Oh, there we go. No damage, no pad problems or anything like that. So, oh, hang on. There's no through hole on them. But yeah, here, one or two of these look like there's no pads on them. Maybe it's just oxidisation. But there's nothing on the top side anyway, it's all on the bottom side here, and they're okay. So anyway, let's put that board out of the way. Let's get that onto the board that we are looking at in this video. I'm going to solder everything apart from that there, because I don't see any point, and I'm not going to solder all 3 of these either, I'm just going to solder one of them. I don't see any point in having 3 blooming grounds, 4 grounds. Right, I fitted a ferrite bead there. There are 3 pins here. The centre pin is ground. So you know, your signal passes across, but then you have a capacitor that goes to ground. So yeah, the signal should be passing through that ferrite bead. We've got a wire joined here just for the +9. So the only thing we need now is RAM and the ROMs. So I'm just going to borrow the ones from the other board. We'll power it on as is now actually to see what happens, make sure we're getting video. The PLA's in there, we've got a CPU. I tested for shorts, and now we've got the chips on the 5 volts is 5 volts, not 5.6 volts. So that was the issue, it's the fact that these were missing, those were missing, those were missing. There was literally nothing on the board, so it seems this is designed to output around 5.6 or more volts when there's no ICs on there, and that I think is in part due to this resistor here. Liv2 was talking to me about this, and I think this is, from what Liv was saying, is when you power it on, it's to ensure that you get some voltage that goes across, because this leads between the 9 volt and the 5 volt rail, and it just provides a bit of a boost to the system before this gets, you know, it's something to do with the 2.2, you need 2 volts, don't you, before that'll start to do anything, and it just assists with that. Let's connect up our ground, and let's connect voltage in, switch the power on, power is on, switch it off. Right, so we've got no ROMs in there. Let's stick the diagnostics ROM in. Bear in mind we've got no RAM either. Let's switch it on again, and we are getting no video, are we? Yeah, there could be a fault on this. Maybe the O2's bad or something like that. Maybe I'm still missing something on the board, but as things stand, it ain't giving us any video, is it? Now it is giving us video because the TV, this here, increases in brightness, so we are getting video. Right, let me borrow the, let me get some RAM. Let me get some RAM in this. So, what are we missing? The only thing we're missing here is basic. Yeah, I guess I need to be looking at clocks next. But I'm surprised. I am surprised that is not moving. We've got 257 there, 257 there. Original RAMs. Yeah, it could be this LS02 here. I might just have to logic probe or scope that. I don't think I see anything else that's missing. We're missing the Zener diode, but that wouldn't be a problem. We're missing ports, that won't be a problem. We have got this ferrite bead here instead of a capacitor. I don't think that would cause us our problem. I mean, I could just get basic on here, but I don't think basic's needed. You know, certainly with the diagnostics ROM, it'll just go, oh, you got a problem with basic, and it doesn't need it to actually boot. One thing I'm aware of is this chip here is untested, and when these don't work, these can give you a black screen. So let's just remove that out of the equation. Nope. Right, so the obvious stuff first. Reset is here, pin 40 on the 6510. Switch it on. Look, stuck in reset. Now there's no reset switch on this. I hope this is not one of these normally closed and you push the switch to open it, because that could explain it. So let me just measure on the other board. Yeah, and I think that may be the issue, because if you measure the top two pins, they're short, and you press the switch in and it breaks them. So I'm just going to solder those top two pins on our board together. Obviously need to try and source a reset switch for this as well, something I'd overlooked here. And yeah, we'll just let that cool and we'll try again. So just a sanity check here, make sure nothing's shorting, everything seems okay. Switch it on. Still nothing. Let's just check reset again. Still stuck in reset. There's a 555 on here. I never even noticed that until now. That's where it comes from, but it goes to pin 1 and 2. Well, it goes to pin 2, I think, and comes out on pin 1, forget which, it might be the other way around, 1 and 2, on the 06 here. And there should be a resistor on those, because it's an open collector. So let's just check that. I may need to just toggle the power supply with the other hand here, so let's switch it off. So probe that one, switch it on. So it's just low, switch it off, switch it on, well, that's just high. So the inverter's working. What seems to be going on is the 555 ain't doing anything. So is it just a borked 555? Let's just measure on the resistance to see if we've got the pull-up. There should be a resistor pack somewhere near there. I hope it's not missing. It's probably this resistor pack here actually, because it's 1K. So just a quick review of the schematics here. You can see the two pins I've highlighted there on the 7406. That's where I was at logic probing originally, where you could see, you know, a high on one side, a low on the other. So the inversion was working, and you can tell it's an inverter because it's got that little triangular symbol there that shows, you know, that's a buffer. And it's got the circle on the end, so you know it's a buffer, and the circle means inversion, yeah, or not. So yeah, whatever you put as an input, you know, high, you get a low on the output. You put a low on the input, you get a high on the output. But because it's an open collector device on its output, that means it can only pull the output low. So it's that kind of like low or floating type thing, really. And that's why you need a pull-up. So the pull-up will pull it high, and when it's got a high on its input and it wants to output low, the low will, because the pull-up is weak, you know, like 1K, the output there when it pulls low is a lot stronger than the resistance that, you know, that leads to VCC to 5 volts there. So it will pull it low. Anyway, the point is, the next thing we need to do is check that 1K resistor. And hopefully you can see the two together. So it's between this pin and VCC, I think. So let's just measure from VCC. It's going to be a pull up. It's not capable of pulling it high. I'm not sure if it's that pin. No, it's not that one, it must be that one. Yeah, 1K. So it's that the output is pin 2, the input is pin 1, but we're not seeing it. We're seeing the inversion. We know the pull-up is there, look, 1K. It's the 555 or something related to that, like one of these caps maybe, or a resistor. Could be a bad connection maybe, but I think it's got a borked 555. That's interesting, because that will be the first time I think I've ever had to replace the 555 on my channel. Yeah, the resistors and things around there look alright, so let's just pull off the 555. Try and get under there again. There we go. No pad damage. So let's get I'll clean up around there with a cotton bud, and we'll get a socket on and get a new 555 in. Right, a teeny tiny toey 8-pin socket there. Let's flip that over. If anything, I'm happy to be using one of those. Just like I say, I've got crazy amounts of those sockets, and there's hardly any ICs with 8 pins. Yeah, I've got loads of 555s here, so let's give one of those a go. So pin 1 is to the left here. Right, let me move all these things out of the way. Let's see if that is now any different. Let me now switch the power on. Hey, it's working. There we go. It was a reset problem. So is that what stumped whoever looked at this in the past? That's what it was, a borked 555. So we have our second board up and running. Woohoo! Right, I need to test the keyboard next, don't I? But that is brilliant news. We now have 2 C16s repaired here, thanks to Sparks UK. So next thing I want to do on this board is test the keyboard. But in order to do that, we need a keyboard pin header. This is one I removed from C64 previously. So I'm just going to micro adjust 1 or 2 of these pins in order that they're all exactly the same height there, I think. And we'll just get that in position and solder it on. And there we go, keyboard connector on, all nice and level. And nice and straight. Switch it on. We've got the screen up, and if I type 1, 2, 3, 4, 5, 6, 7, 8. Whilst I'm waiting for the remaining bits here, I'm going to start to clean up. So we'll clean up here first of all. We've just done the keyboard connector. But any of the ICs that I've fitted on here now, you know, the sockets, that's where I need to focus. So there we go, after about half an hour of cleaning you can see all the solder points look really good there. I even cleaned around the ports here. I removed the flux from the modulator point. I'm going to remove that modulator again now and stick it back on the first board, but yeah, you can see it's not too bad. There's a little bit of flux here, still needs cleaning off. I even cleaned up around the switch and stuff there. So yeah, there's a few things obviously I'm waiting for now. I'm waiting for, I need to source a reset switch. I'm waiting for the transistor, I'm waiting for the Zener diode. I'm waiting for a port for there, I'm waiting for a port for back here. So yeah, I'm just going to put this on hold until those things arrive, and I'll report back in a minute. So the diodes have arrived, actually before I finish part 2, and that's D041, 6.8 volts. Looking at the requirements for the original diode, this is rated twice the amount of current, so it should be more resilient. I think it's a bit small, but yeah, it's twice the rated current. I've also got these ports now as well, some 7-pin and some 8-pin ones, so we'll fit those. And that went straight on. I did have to cut the wings off to show you. This is one of the 7-pin ones. Yeah, these wings here, there's nowhere for those, but there is the sensor contact, and the pin spacing is identical. It sits maybe a millimetre further forward here, but yeah, you can replace them. And that makes it all the more strange to me that someone would take them off the board. So yeah, we cut the wing off again because the interfere. This one is proving a little bit harder to go in. Maybe the spacing's different. Nah, look at that. Let's try it on. There we go. Oh, there's something amazing feeling when you fit a brand new port on something like this. Especially when you thought that maybe it was bespoke in some way, but no, it isn't. So the legs there were marginally wider, so you'd have to use the dowel just on both sides. As you can see, though, it's in there. I bent it deliberately to the side away from this resistor. Yeah, this is obviously going to add heat. It's a 5-watt resistor. It does get just lukewarm after a few minutes, but nevertheless, it is a factor in the life of these diodes. So I've got another C16 case. It's broken in almost the same place as that other one. Now you can see these white bits here. I saw the advert for this. It was dead cheap. It was £5 with £5 shipping. Now there's a ripple here. We can smooth that out. In fact, I'll just have a go at that now without taking it off. One thing you can do when they're bulged up a little bit like that is roll over it with a rubber implement like this. You can see that's almost gone flat. That's almost flattened. Yeah, and there's a little bit more there. Sometimes using the end like that and just, hang on, not rubbing because you rub the ink off. Rubber handle is better because the rubber won't remove the print or scratch it, but just a bit of pressure on that point. You can see that's almost flat now. Yeah, with a little bit of work, I reckon I could get that way better. Is that better? I think it is actually. I think that's almost flat now. Anyway, yeah, the bits here, these white bits, I think we get some plastic glue on this, have a gentle polish around, and I think it's super glue. You can see actually someone has glued it on the inside. And you know what? I found the sweet spot straight away. With the first temperature I was using this to heat shrink for 150 degrees. There was a stress mark here. Yeah, I'm not sure if you can see it now, it's gone. All it is heat around here, just for like several seconds, and it's obviously not hot enough to melt the plastic on the other side. So can you see this mark here? There is a white mark there. I'm not sure if that's going to get picked up on the camera or not. Yeah, so I just moved the camera up a little bit. Let me just see if I can see that on the viewfinder. Yeah, there is a stress mark here, you're going to have to trust me. And I'm just going to heat around this, 150 degrees. Change your colour already, change your colour, it's changed. That white stress mark has gone. It's gone, completely gone. And this side, because we've not heated enough, obviously there's nothing visible. So let's now try on this stress blemish here. Obviously, it's different on a textured surface like this, but anyway, let's just heat. Pull away. Angle, so I can see what I can see and you can see clearly as well. Let's just heat here again. See it change colour? Yeah, it's changing colour. I don't think 150 degrees is hot enough to melt it. That's almost gone. Yeah, hopefully you can see the difference there. That has almost gone. So I'm not going to go overboard, but that is already improved. There's still a little mark here, just a bit up there maybe. So yeah, just make sure it's cold. Yeah, it is. I think 150 degrees is pretty safe. It's just above boiling point, isn't it? Let's just go wider afield. Yeah, there isn't a regular shape to that, certainly at that point there. You know what? That's almost gone. Can you see that? That is almost gone. There's definitely a mark there that you can tell that the plastic has been affected in the past by the knock. But you know what? That mark has gone. That is gone. I'm really pleased with that. So there's a scuff here. Let's just see if we can get rid of that little scuff. Can you see that in the light? So let's just heat. Yeah, that's going to take a few goes, I think, because obviously the surface is scratched. You know what, even that is better. I'm just going to let that cool a minute. And obviously we can polish this at the end. Yeah, I'm very surprised. I'm very surprised that that has had such an effect there. You know what, that is 1,000 times better. This scuff here I can't do much about. By the time I've polished this whole thing, I actually think you're not going to be able to tell. Let's have a go at this bit here, just to see if that will change colour at all. Or is it super glue? No, look, that's changed a bit. I noticed a change in colour there straight away. You know what, I am amazed. I am absolutely amazed. I feel like doing this, it's like erasing the mark. You could argue it's made it sort of wider, but it's more uniform. It's not got this big white patch as it had. Yeah, and I think by the time I've polished it, it might be a lot better. Yeah, right, I'm going to leave that there for now, because you can see it's, you know, it's kind of like, it's made it less white around those bits, but it's kind of like faded it out a little bit. But I still think the polish could sort that out. Are there any other cracks or anything on this, or any other stress marks on the inside? I mean, the obvious thing here is not just gluing that, you could melt with a soldering iron across that there. There's a stress mark there, can you see that? A really big white mark there. So that has been stressed at some point in when it got impacted. See, look, changing, look, the colour's gone. Back to a normal colour look. And if you look at it in the light, you see it's not malformed or anything, it isn't. So, I mean, it's not like added loads of strength to the plastic there. All it's done is melt the surface there so that it's more uniform, not uniform. Yeah, there we go. Happy with that, very happy with that. So a huge shout out to Retro Crazy. I'll post the link down below. I think when he tried this, he went too high, and whatever he did, he melted, and he was like, oh, I should have got a lower temperature. And this is why I said you start maybe 100, then 120, 150. Now I started at 150, but you know what? Look at this here. It was like a, yes, you can see the lump because that's where it's had the impact, but the white part around it is gone. By the time that's polished, you won't be able to see that at all. It was quite a noticeable mark here. A bit like that there from that scratch. This, I think, is better. So you can see with a bit of back to black on there, all these marks have come off, actually. You know, it looks really shiny now, but you can see, obviously, the crack. There's a stress mark here. Can you see that? It looks white. Yeah, I'll try and keep that on the camera, right, just watch. Watch it change colour. Changing colour, gone. Very much. And obviously a little bit just there, so I'll just eat that bit. It's probably worth, I don't know, I found that you get a better result if you put some back to black on it, which is a silicone, and then heat, and it's kind of like embeds it into the surface, actually, and any, like the white mark that was here is gone because of that. So it's like you're just heating in a bit of silicone. Can you see that? That's perfect. That's flipping perfect. And here was perfect. That mark's gone. Yeah. The slight indent here is because of the post on the inside. That's not from here now. It's remarkable how much better that is. If I got to this before someone cracked that, do you know what? I could have made that almost seamless. They just didn't glue the plastic back in the right place. You know, it wasn't properly aligned. So there's like a white bit around there, those are a bit stressed. So, you know what? Let's just have a go with that. Change colour, back to normal. But again, it's probably, you know, it's less important on the inside because it's just an appearance thing. We're not going deep enough for long enough, high enough temperature here to properly reform the plastic in any kind of structural way. But what we are doing is just getting rid of the surface stress marks, I guess. And I guess the same thing would work on C64 cases as well. If you've got any of those problems with a C64 case, you could probably do the same thing. I might have a look at my C64 and see, that one's got a missing clip there, look. Might have a look at my C64 case and see if I've got any stress marks that I might be able to try this on, but I will try it on the inside first. Always test on an inconspicuous area that's not visible. So there are some scratches here on the front. I don't expect this is going to make much difference, but you never know, it may just change the colour a little bit there. Yeah, it's got lighter if anything. But you see, as I say, one of the things I noticed, and this stuff's flammable by the way, is if you polish the area you want to do this on first with this, and again, don't follow this as any kind of this is what I'm doing. If I do this, if I put this on, this is what's happening, because it could be toxic, you know, I don't know. I'm not going to be responsible for anyone getting ill doing this, or having serious health problems, or dying, or whatever. But you can see, right, that's a lot shinier, so let's just get the hot air out again. And you can see straight away it's removed most of the scuffs and things there, but just by virtue of using the hot air, once you've done this, seems to make the process work better. Yeah, that scuff there is way better. Way better. Scratch, not going to be able to do much with that I don't think, but we'll eat it anyway. And if I was to guess, I would suggest that the silicone is perhaps bonding better with the surface, I don't know. You know, the plastic kind of absorbs it. If you clean the plastic like this with IPA, it goes all white and horrible and patchy, and that's where you need to use this silicone polish. But yeah, I am very, very pleased with that. Got a super bright red LED here. It's clear on the outside, but it's red, and we can hopefully just get it into its holder there, and there we go, clips in. So it's nice they left that there. Yeah, so it loses the wire there. Someone has tried to gouge this out. There's a little bit of the paint missing off the bottom. And despite this being a lot flatter now, there is a gouge there. They've tried to lever it out at that point. That's why there was a ripple in that. But anyway, I'll now clean this with an eraser, as you've seen me do before. So the next thing I've done here, I've just clipped, so there's like a little ring that goes around there onto the, this is the one from the previous video, sort of the case. But we need a wire for the LED, so I've just measured up against the original wire here, from the one in the previous video there. And yeah, made this about an inch longer, just because when you twist them together, you lose a bit of distance. It's going to be slightly longer, I think. And I've got a 3-pin JST here, 2 pins to, you know, obviously fit these in. Twist those together a few times at the start, and then separate the 2 wires like that with your finger, and just simply twist them together. It's obviously easier once you get something soldered on, like the LED or the JST connector. So you've got a slight mismatch in length there. That always happens as one, obviously, you know, spreads out further than the other. But yeah, and then obviously you can, you know, if you still feel it's like it's not, you know, the spacing's not the same, you can just do a bit of that just to try and even it out. But anyway, you can see that that's not going to be bad. So I'll leave this end for the LED, I think, and we'll solder those onto the 2 pins here. I need to cut them off the little stub. So anyway, just move it up a little bit like that. I'm not going to have a very long length on this, and I'll try and cut that like that. And we'll cut the other leg to approximately the same length. So here's the cable I've just done. So you can see that looks fine. Centre pin in the black, just the same as the original one. It even looks the same colour, the JST there. But yeah, we're going to need some heat shrink. The only colour I've got is blue. So yeah, we'll just unwind those out a little bit like that, so you get a bit of length. Chop the red down to the same length as the black. Yeah, so I just need to strip the ends off, solder on, but before I do that, I need to work out which one's positive, which one's negative, I can't remember. So obviously don't work on your knee like this, it's just easy for this LED. So yeah, positive is nearest the top. I've pre-tinned the wire ends here and the LED. The other thing I was looking at when I did this, you can see these here, you know, I was looking for stress marks yesterday, look, you can see them all over the place. You see that one there? So, yeah, there is maybe mileage in going to maybe slightly higher than 150 degrees, but just watch that white mark. Yeah, I'm not sure if you're going to be able to see that because I'm blocking it. But it's more or less gone. There we go, it's gone. but it is only surface, isn't it? So the next thing we'll do on this board is get this transistor in. It's a tip 29. I think it's got a revision on the end, like an A or a C or something. I'm sure it'll be alright. Why are those legs stuck together there? Yeah, bear in mind they're sensitive to static, so make sure you've got a wrist strap on. I should have had that on. So we just need to bend these over in some sort of appropriate way, like that, and then feed them through. There we go, that's it. So let's just flip that over, see if it's straight. Yeah, it's a wee bit crooked there. You can see the tab is touching there. And this is what you want to be careful of. That tab is going to be connected to one of the 3 pins there, so shorting onto that ain't going to be a good thing. So I'm just going to heat and just pull it sideways a little bit. I probably need to heat all the pins at once here. There we go, it's shifted. And then just heat them individually and just inspect to make sure they aren't shorted. You can test on continuity. Yeah, that's it, that'll do. And just trim those off, clean up and inspect. And there we go, so all the points looking nice and shiny on both sides. So yeah, the only other thing I need to do is maybe isolate here a bit. I don't want my heatsink to touch on this pin. We've got the kernel here from the previous C16 you saw, because that's got a custom one for the 6510 that fit on there. This doesn't need it. But we do, however, need a basic. So I need to program up a chip and get a basic on here. And I took the modulator back off this to put on the other board to finish that off in part 2. So I need some solution to the video. We've got no video out at the moment here. So what I'm going to try and attempt to do here is we've got a little amplifier board here that is designed for you know, amplifying the S video, you know, the chroma luminance and composite providing them. For the C64, I guess the circuit isn't going to be all that different. And if this works, I guess it's just something else useful, really. Because who would want an RF modulator anyway? If this does work and gives us some nice crystal clear video, it's got to be a positive thing. So yeah, the next thing I need to do is just, I've got the pin out actually on my phone from the RF modulator on a C64, one of the bread bin ones. And obviously you've got, I've shown this before on one of the C64 videos, there's like a set of pads on the top there, one on the bottom one. The bottom ones are for long boards, so that's the bread bin ones, and the top one's short board. So the top series of pads there are for a C64C/E, you know, the short board. Yeah, and then once I know those pin outs, I just need to work out what the pin out is here for the chroma, luma, you know, 5 volts, ground, and I think that's it actually, in theory. Because once you've got those things, once you've got the chroma and the luma coming in here, the power and the ground, I think that's probably all you need. There might be another signal there required, but I don't think so. Right, I'll show you some of this, trying to work out the pin out here. I've drawn a little diagram of the pins as they appear here, you know, the 8 points there. Looking at the schematics, pin 3 is VCC. Now there's no markings here to show you which one's which, but I just tested from one of the 7.4 series here, you know, the topmost pin on the 7.4 series is the VCC rail. And if we go to that pin up there, yeah, third one up, 5 volts. So considering the schematics say pin 3 is VCC, it's easy to assume it goes 1, 2, 3, 4. So 4 on the schematics it says is luma in. So that would make that pin 4, and on the TED here, pin 23, which is there, it's got 24 pins on each side. There you go, that's luma. So that's the luma out on this effectively, but it's in terms of the modulator. You know, so you have a luma in, a chroma in, and then each of those gets amplified and pushed out for S video, and then they're combined, and yeah, it gives you composite. So yeah, that's correct. 1, 2, 3, 4. I'm not sure where 5 is. Is it here, or does it go down this way? So the next one, and I'm looking at this page, the schematic here, there's the modulator, M1. So 5 is colour in. So we've had a luma in. 5 is colour in. So let's assume it's that one there. And colour in, if we look at this page, the schematic is a lot of to and fro here. Yeah, the colour is there. And that's pin 13. So yeah, let's assume that that's 5, and let's just whiz down here somewhere. Well, it's not that one, is it? This must be 5. Must go 1, 2, 3, 4, 5. So let's see if it's down here somewhere. Yeah, there we go. And we can count those. 1, 2, 12, 13. Yeah, there we go. So we know now that this pin here is 5. So I'll just stick a 5 there. It's going to be 6, 7, and 8. And that one is call in. So that just leaves the outputs now. And as far as you can see, that's it. Pin 2 is sound. We're not using sound because we're not using a modulator. So you get 5 volts, luma in, and then color in, color out, composite, luma out. Through some inspection of this and measuring around, I worked out the pin out here. So on the longboard pads from the right hand side here, VCC, luma in, chroma in, composite out, luma out, colour out. The ground obviously is the single pin there that usually goes through one of the holes on the C64. So I think what I'm going to do is just cut a sliver of this double-sided tape, stick it under there, stick it down approximately there, and then just use some wires. It's going to be a bit bodgy, and you know what, I may need to take it back off yet because I may need to change some of the components here and trying to heat with hot air and with the tape, and I don't know. The whole point is I'm just going for it broke here, and I'm just going to assume that the chroma and luma are going to be very, very, very similar in level to what they are on the C64. It would seem perhaps ridiculous to assume anything other than that. Why would you, if you were designing something like the C16, why would you reinvent the wheel kind of thing? See what I mean? So I would assume that that chip is going to be doing the same sorts of things that Commodore had already done. But then again, you never know. If a different designer is designing those chips, it could have been sort of done from the ground up. So technically, this may get melted a little bit by the soldering. Yeah, so I'm literally just going to stick that. Yeah, that's not going anywhere, is it? It's fairly straight there. Right, that's it. Bodgy wiring done. I will clean up in a minute. Obviously, I don't know if this is going to work or not. Place your best. Do you think it's going to work? I've got a feeling it's going to work, but maybe the attenuation on one or two of these signals might not be right. But then again, it may just be perfect. Yeah, so I've set it to 9 volts 1 amp. Let's power that on. I need to switch the power switch on. Anything? Oh, hang on a minute, video cable's not in. Oh, God, I'm talking about stressing me out. Let's try that again. Hey, look at that. Alright, there are some slight jail bars here, but that's not bad for a first attempt, is it? Modulator. We don't need a modulator where we're going. Let's just get rid of that. Oh. Yeah, very pleased. Oh, hang on, blooming on-screen display. There we go. Yeah, very pleased. Mission complete, I think. So I'll test some games and stuff on this now, but I mean, this is really good news because this means this one is another one that is 100% functional. Well, so far. I need to test the tape port and stuff next, I think. Yeah, I soldered that bridge there just now. It's changed the luma. Obviously, it relates to luma. I'm not sure it needs to be in that position. I'm going to leave it with that bridge now, using the keyboard adapter you saw me build in a previous video here, so that I can get a C64 keyboard. So that's that. So we'll plug that into the first joystick port, I forget which one's 1 and which one's 2, that's that in. And we've also got the tape adapter you saw in the previous video. I've not, at this point in time, not put the housing on that, actually, the shield, the plastic covering. But anyway, it goes this way up. And I'll connect a data set, and I got some tapes. You'll have seen me load some tapes in the previous video, but we'll just give the data set and go with this. So we're testing a few things here, because obviously the transistor's fitted now. This board hasn't been modded with the kernel there, you don't need to mod, or is it basic, I forget. I don't think it's the kernel actually, you don't need to mod the kernel if you are using 6510. This has obviously got Lotharek's 6502plus4. We'll load Exploding Fist, that's a super short load. Anyway, let's just switch that on. And let's rewind. Yeah, so the tape port's working. Data set port, I guess you could call it. So it's certainly a Frankenstein C16 at the moment, but anyway, let's do load, press return, press play, it detected that on the screen. And what I mean by detected there, when you press play, the system is able to, the CPU actually via one of its I/O pins can determine you've pressed play. Found exploding fist, press control. Now one problem, oh yeah, it didn't, I was going to say one problem you can have when you do the ROM mod, the kernel mod, and stick 6510 in there, because it's one I/O pin short. I think instead of 7 I/O pins it's got 6 6510, and the 7501 or 8501 CPU have got that additional I/O pin. You can't stop the tape. And that can cause some problems loading certain games. But anyway, yeah, in this case here, the magic that Lotharek has done with the
6502plus4
is he's decoded that additional I/O pin there. So it behaves just like, that's normal by the way, it behaves just like a real 7501 or 8501 CPU. So yeah, brilliant job Lotharek. You know, it's kind of two things in one video this, isn't it? We're covering the repair of the C16 here, but at the same time we're testing out the product from Lotharek here, and it's a really nice way to replace the CPU actually. And having done the 6510 mod in the previous video, I would go this way and I would actually get Lotharek's chip, because you don't need to, you know, you've got full compatibility. You don't need to worry about having to do the mod underneath with the diode and do a kernel swap out, etc. I think the instruction set is exactly the same. You know, over the years there were people that were trying to convince me that the 6502 is it's got one or two differences in the instruction set, or certainly, you know, unsupported opcodes versus 6502. But from what I understand, the 6502s using here are exactly the same in terms of the opcodes and the unsupported opcodes. And I think this proves a point I made in the previous video, that on some tapes the pause delay there, you know, where it comes up saying found, in this case it said found scramble 16 I think, and then it stops the tape, and then you press the Commodore key, or a pause of so many seconds you know, occurs, and then it starts up again. And if you don't get that timing just right, you either miss the start of the next block of data, or maybe protection kicks in and it goes, hang on a minute, you know, you're cheating here, you've got a copy of the game. Because that's worked. Yeah, this would not work with the same data set, and I tested this tape over and over and over with the 6510 in part 2. So yeah, I've got 2 more tapes here that wouldn't work. I'll bet those will work as well, so I'll try those next. But anyway, that has loaded. Yeah, there we go. Sweet. So yeah, very VIC-20-ish, isn't it? As I said, oh, you've got to shoot those, haven't you? I prefer the VIC-20, I think. But you know what? It's still a nice little machine. So this is the second of 3 tapes that just would not load at all on the 6510. Press the Commodore key. Yeah, and it paused then, as it should do, due to, as I said, the amazing address decoding implemented on the 6502plus4 from Lotharek. Yeah, now this is what it normally did, and you press run, but the tape stops, you see. Then you get a green screen and it continues. Hopefully that may load. That took an incredible amount of time, like 7 or 8 minutes. Joystick, yes. There we go. So yes, another example of the 6510 not being the best solution. So it's a ZX and return. Yeah, the joystick is working. Hang on, can we fire? Yeah, we can. Yeah, so I think because I chose joystick, the return to fire doesn't do that. I probably would have needed to have selected keys. So it came over already. Good God, that was quick. So I've only got one more tape to test that wouldn't work previously. I think that was Mr. Puniverse. And I guess that's another one of those that now we've got, you know, that port working for the tape. When I say port, I'm talking on the CPU, that additional I/O pin. Then I reckon that one will work as well, so let me try that. Yep, and that worked as well. So that means all those tapes that I bought worked. That wasn't bad, it was like 7 or 8 quid for about 20 C16 cassettes. Am I right, they had no boxes, but that's still pretty good. How do you start this? F1. Yeah, that's not exactly a good design choice, is it? Because I'm like stuck here. So I cleaned around that with cotton buds. I'm just going to finish cleaning this board up now, and then we can get it into the case. This one has like a double diode sort of mod around here. That other board didn't have that, so I'm not sure what that's all about. So I did spend about an hour cleaning that actually. I'm now just going to mask off around here and just clean these. The other thing I do need to do something with is this, because can you see this heatsink? It can slide to the sides and short to the pins. So yeah, it's because it's not the right style of heatsink. Right, so I've done the 64K mod again there. If you want to know more about that, see part 2. We've now got 64K. For the heatsink there, just a couple of pieces of heat shrink actually. It's really tight on those two edge pieces. So even if this rotated, it can't short anywhere. And obviously I can tighten that nut up there just to make sure that's really tight. I mean, technically we've got a lot more than 64K here, haven't we? Because we've got, I think it's 512K on the chip from Lotharek there, the 6502plus4. We'll try and find some way to use that RAM actually. Here's a cool little demo. Look at that! Colour's amazing, isn't it? Looks just like the C64 version, if not more colour there. Pretty cool music as well, yeah, it's a demo. I think it's called Ghosts and Goblins Arcade Music or something. Just turn that up a bit. Yeah, so it's kind of like a rendition of the SID music, isn't it? So I managed to squeeze 3 heat sinks just on the edge of TED there. That's just going to help dissipate the heat. That's hot already, it's only been on a minute or two. The 6502 here, it's a modern part. There's no worries about that getting hot at all. So the other nice thing with this is it's got that additional RAM. Now, I can't really find anything that makes use of that additional RAM. There is software out there. I've got a couple of disk images on there that came with one of the 256K RAM boards that you could buy back in the day. And what that does is, one of the things on there is some file copy stuff, disk copy software where you can, make use of that 256K to copy a large number of files, or a disk. Easier if you've got a disk drive connected. But the other thing that comes with this obviously is this pin header here, and it does clearly say in the instructions if you want to provide the Haynes 256K mode, you stick a wire from here down to here, FB40, that's the CAS line, but you remove the RAM. Sorry, there's the RAM, those are the 257s. It just dawned on me, actually I could do that. You may even not need these 257s, I don't know. I suspect you probably do need those. But anyway, or maybe not actually, I don't know. I'm just curious to see, can we remove these 4 chips here, yeah? During this wire up, will it just work? If so, it means I don't need the 257s, it's an Achilles heel out of the way, and likewise the RAM, and I can reuse that RAM because I've really not got any of that RAM left. Right, I desoldered the 2 wires from the PLA, so let's just take these out now. A short little wire here, 5 or 7 strands I think that is, so it's flexible, and I got a single DuPont connection here. Yeah, it's the sort of, I don't know, the 254 pitch type, but a single, and the pitch isn't relevant because there's no pitch, there's a single pin. Yeah, so that's going to go onto there. I just need to now see, is that wire long enough, can we? Yeah, we can stretch it down there. So all I need to do is simply add a wee bit of solder to the point here, left side of FB40. I think, if I can see what I'm doing. Yeah, there we go, it's quite a beady solder point that. I need to make sure that's not shorting. Solder our wire to that, making sure it's not bridging anywhere crazy. It helps if you can see what you're doing. I'm so far away here. Yeah, I think that's it. And I am assuming that is the correct point there, so let's connect it to that. I'm just going to inspect that with magnification, and then we'll try and power it on. Yeah, that looks okay. I'll add some flux and reflow in a minute, but one final point is we test here. We've got a short to the CAS pin where the RAM would have been. So yeah, I think that's okay. So I'll switch the power on, see if we get anything. Hey, there we go, we've got no RAM and we've got missing 257s, so there you go. I'm quite happy with that, because it means I've managed to reclaim those chips there for use elsewhere. And we've got the 64K report there. So yeah, as I say, I'll now test it with the diagnostics ROM again, just see does it actually show any more than 64K in that ROM. So testing with the diagnostics ROM, I'm not sure that is working actually, because it's just flashing like that. That is interesting. How is it that basic was able to start, unless that's testing all the banks of RAM, I don't know. The interesting thing there is there's some sort of issue with this. I might just let the author of this know, drop him an email or something. I've reinstated these, doesn't seem to make a difference. Obviously I've got the address lines for those, the extra connections there wired up as well. Not sure that's correct, but in any case it's doing exactly the same thing, where it just sticks on that screen. So yeah, that is interesting. And with the original ROM back in, that is all working, as you can hear. I think I'm just going to leave it that way for the moment. So, yeah, it's annoying the diagnostics ROM has some sort of issue, but that may be something that the author of that diagram could fix. He probably needs to get his hand on one of these 6502plus4s. I might see if Lotharek can send him one or something like that, because that would be really cool if that ROM could be updated, maybe to test the RAM on it as well. You know, the additional RAM. But a huge thanks to Lotharek for creating this product. It's really good, isn't it? Because it's replacing the RAM. You don't need the 257s here either. And it's compatible with the tape stuff. You know, it's doing the decoding there for the additional I/O pin. It's just a really nice product. The other thing is, if you've got any concerns about opcode compatibility and stuff, it's the NMOS version, I think this, of the 6502. It's not the 65C02. So it's opcode, you know, its instruction set. It should be 100% compatible with the 8501 or 7501. So yeah, I can't see any reason to not go with this as an upgrade option for any C16 or +4. If you've got a working CPU, I'd remove that, and I'd fit one of these, and then if you want, you know, if you're capable, you can get maybe someone else to do it, remove the RAM and remove these. It's less drain on the power supply, it's less to go wrong, and you can always reuse those to fix another C16 or a C64, etc. I can't really explain what happened there, but yeah, those 257s just occasionally cause it to just act a little bit odd. So I've just removed them again. There's nothing wrong with the 257s, but it behaves a lot more normally when they aren't fitted. So that could be some sort of compatibility thing. So just bear that in mind, that it might be better to remove them when using this. Yeah, the TV scrunches up like that sometimes on this display, but yeah, it's going to leave it like that without any of the 4 chips. Filming this bit on the phone actually, just because my camcorder is just out of commission at the moment. So you can see I filled here with some plastic putty. Ignore all this whiteness, it rubs off with the IPA really easily. What I need to do now, the gap is here somewhere. It's filled and it's pretty level. It's not going to be perfect this, but this is excess. So I just need to use a cotton bud and edge away at this for probably what's going to be hours, I don't know, ages. It wears with the IPA though. You can see I've got a keyboard here for this C16. It's pretty yellowed and it's very dirty. There's a lot of dirt, as you can see on this. So I'll stick a link top right to a C64 video. It's the same thing. It is literally the same thing. The layout here is obviously different. We covered in part 2 how to adapt to a C64 keyboard. But rather than bore you with the same things you've seen a million times, I am just going to literally cut to having this cleaned up and reassembled. What I'll do is pull all the keycaps off, put them in the sink with some oxy action, you know, TAED, vanish, and it won't de-yellow them, it will get all the dirt off. And then at some point in the future I'll sunbright this. I'll just put this out in the garden next spring or summer when it's nice and sunny, and it will de-yellow sort of naturally without you know, putting any H2O2 on there. There we go, all the keys collected in there and the springs. I dropped this on the floor when I had 28 springs in it, and I kid you not, I've been on hands and knees for 10 minutes picking them all up. counting them all, double counting them, then I realised I had 27, I had one missing, and spending another 10 minutes trying to hunt for that. So yeah, be very careful you don't lose any parts when you're disassembling it. So please remember, this is not a pristine example of one of these boards by any stretch of the imagination. We've had to do, you know, a bodge here. We haven't even got a reset switch. I haven't got a panel. It's just going to be my test board, this, in a case, which we'll get into in a minute. So I've widened the hole here. This is the positive. Yeah, trying to find anything that will fit there other than from another C16 is proven impossible. So you can see I've modified this DC jack here. I've bent one of the connections out, bent the other one out. The positive is this centre point of the bomb, so it's going to go there like that. Yeah, with a bit more winding there, that will go through that hole. This little tab here will solder onto there, which is a not connected point, but I'll just bridge across to the ground, and then it should hopefully be in position. Right, so you can see where I bent that leg out and soldered it onto the middle pad, and then I joined the middle pad to the positive side here. Obviously we've got our ground soldered on there. It's pretty central, that. So it's almost in the same position it would be originally, maybe slightly more to the left, I'm not sure, because it may have been more central in respect to that pad on the right there. So, but I'm not too bothered about that. The main thing is we've got a DC jack, it's pretty straight. I could just bend it marginally that way, but it's nicely secured there. I just cut the extra leg off the top there. There's just no point in even putting some heat shrink tubing on it. It just serves no purpose. And yeah, that should do it. But just test it. So from the shield here, this is ground, so it should be centre point ground just on the tip there, 0, 0, 0. And just to make sure we haven't got a short to the 9 volts at the bottom, no, down. And then from the bottom point of this cap here, which is the 9 volts in, yeah, I got a join to the outer, but not on the centre. So yeah, that should work. I'm going to connect up to the bench power supply again. I'll obviously feed through the DC barrel jack here, just make sure that's working. Yeah, that's working fine. Power LED there, and then obviously our keyboard connector, pin 1 to the left. You know what, other than this mark here, it's alright, but I really should paint that, I think, but you know what, I'm just going to leave it. It just tells a little bit of the tail, and it's flat and it looks okay. It's super bright, look how bright that is. Yeah, so it's yeah, my crusty C16, but it's mine. So the best advice I can give you for sizing these so that they don't stick, you know, on the case and stop it from going in, is that arrow there. All I did here, it looks a bit rough at the moment because there's just a few strands of plastic sort of stuck out. Yeah, but stick it on the edge of that arrow there, and then saw into the thing, rotate a bit, try and keep it straight as you can, go all the way around. So it looks rough, but you know what, it isn't. It's just like little edges, it's just like little pieces of plastic that just need pulling off. And that just means that when you come to put it in here, it goes all the way in. Yeah, there's enough distance on that now to fit perfectly. And there we go, all done. So a huge thanks to Lotharek for sending me the 6502plus4. That is really good. I'm going to keep this machine, as I say. As soon as we get to spring, summer, you can see the yellowness here. I'll sunbright this out in the sun, and the keys will come up looking nice and grey again. Good retro bright, but yeah, I'll just let the sunlight do that naturally. Yeah, I mean, I could paint this, but as I say, it's nice and smooth now, and it's solid. The epoxy held on the inside, the screws held really well. For the keyboard here, I had all of those, and I had 3 spare screws for the case. So yeah, it's all gone together really nicely. I did trim those down, as I sort of explained, just use a knife to cut all the way around there. And obviously a huge thanks to Sparks UK for providing the boards for all 3 of these videos as well, and Ted, and also Alex, who provided me 2 Teds previously, I think. So yeah, those have been super useful. It means I've got a spare Ted, and both of these C16s have been repaired. And it goes without saying, thank you very much, Daniel Mantione, as well. We couldn't have got these boards up and running without your modern PLA replacements. There'll be links down below to Daniel's web store, Lotharek, where you can buy a 6502plus4. You've got to be crazy to own a C16 and not fit one of those, in my mind. the 7501 and 8501 are going to fail, and if you fit a 6502plus4, you're going to be able to have the 64K RAM without doing the RAM upgrade, and you've got the Haynes 256K if you want it, as well as it being a lot more reliable and robust, and your tape stuff's going to work. So the 6510 mod we covered in the previous video, it's a nice way to get up and running, but the 6502plus4 is far superior. Anyway, I do hope you enjoyed this series. I'll probably show some more C16 stuff in the future. Thank you very much for watching. I'll catch you in the next video.